Hello students. In this video, I'm going to teach you optimal binary search tree. In previous video also, I have recorded one video on OBST, but that was by using a general programming approach. In this video, I'm going to teach you OBST by using dynamic programming approach and what are the different advantages of dynamic programming. So we know why we use binary search tree. Okay, there are two types of binary search tree, static BST and dynamic BST, and OBST is the type of static BST. Now consider the example. If there are four keys PQRS and that are having different probabilities are given. Okay, so how many BSTs can be constructed for these four keys, right? So answer is there can be different there are different 14 possible BSTs that can be constructed by these for these keys. But which one is optimal among all these 14 keys? How to find out that? For this, in previous lecture we have derived this formula, right? So this is the formula that can be used to find out the optimal BST. Okay, but this formula is the general formula to find out the BST. Okay, what is an OBST? OBST is a BST with the minimum cost, right? Now consider one more example. Suppose there are three keys and the probabilities for successful search and unsuccessful search is 1 by 7 for all I. Now we have to compute the possible BSTs and we have to find out the OBST, right? So there can be more than one BST for this keys, okay? But among these keys there will be only one optimal BST, right? So if we find out this OBST by using general formula, then first we have to find out the number of possible BSTs. So if the keys are 3, then there will be 5 possible BSTs, right? So these are the 5 possible BSTs for the given keys. And now using the general programming formula, we have to find out the cost of each tree, and whichever tree has the minimum cost, that tree will be the OBST. So if we applied the formula given on slide 5, so we'll get the cost for each OBST. Now observe the cost carefully. After applying the formula, the cost of these four trees B, C, D, E are 15 by 7, but the cost of first BST is 13 by 7, and that's why, as the tree A having a minimum cost, we can say that this tree is the OBST for the given problem, right? So for this problem, these are the possible BSTs, and among this first BST is the OBST, right? So till this I have covered all this thing in my first video. Now the main aim of this video is just to give the idea of how to solve the OBST by using a dynamic programming approach. Okay, here I am just going to give the overview of this because the problem problem is mm, problem takes a time to solve the any OBST problem, right? So I'm going to just give the idea how which formula you have to use and how to find out the tree and what are the advantages of finding OBST by using dynamic programming approach. Okay, so why the general programming approach is not useful, or why generally the dynamic programming approach is used? Because the disadvantage of general programming approach is that if the number of keys increases in a BST, then the number of BSTs are increases, and as the number of BSTs increases, it takes time to find out the cost of each BST and among from all this BST to find out the OBST. So generally the dynamic programming approach is preferred to find out the OBST. Okay, so this is the formula to find out the OBST by using dynamic programming. Okay, so W of ij. What is W of ij? It is the weight of a node ij. Okay, so W of ij is equal to P of j, that is the probability of j plus probability of Q of j, P of j for successful search, Q of j for unsuccessful search, probability of unsuccessful search plus weight of I comma j minus 1. Then C of ij. C of ij is the cost of a node of ij. W is weight of a node ij. C of ij is the cost of a node ij. Okay, so the cost of a ij is equal to minimum of a lies a is greater than I and less than and equal to j. Okay, C of I comma a minus 1 plus C of aj plus W of ij, and R of ij is equal to a. R gives us the root. Okay, here while finding out the C of ij, this C of I comma a minus 1, that is the cost of a left subtree, and this C of a comma j, this will give you the cost of a right subtree. We require this to find out the final tree. Okay, so just remember this thing. Okay, so we have to remember all these formulas. Okay, so this is the formula W of ij, that is weight of ij, C of ij, that is the cost of ij, and R of ij is the root of a tree. So we have to remember all these formulas, and considering all these formula, we have to solve the OBST by using dynamic programming approach. Now consider one more example. Okay, find OBST using a dynamic programming for n is equal to 4 keys. So there are 4 keys for K1, K2, K3, K4, and the keys are do, if, int, while. Having the probability for successful search, the probability is P is equal to 1 as to 4 and probability is 3311, and for unsuccessful search probability is given 23111. Okay, now how to find out? Again we have to consider the formula. Okay, before that consider this structure. Okay, this structure we have to find out the values for W of 0 0, C of 0 0, R of 0 0, W of 1 1, C of 1 1, R of 1 1. This we have to remember. Okay, so in step 1 we are going to find out the values for all these things. Okay, so initially the cost C of 0 0 and R of 0 0, C of 1 1 and R of 1 1. So cost and the root value is 0. Okay, initially C of II is 0 and R of II is 0. Okay, in step 1, and W of II, that is W of 0 0, is equal to Q of 0. Okay, in a problem given Q from 0 to 4 and the values are given 2 3 1 1 1. So we have listed all these values as it is in step 1, 2 3 1 1 1. Okay, so this is the step 1. Okay, in step 2, see W of 0 1, in this box we are going to find out the value of W of 0 1, C of 0 1 and R of 0 1. In this box we are going to find out the value of W of 1 2, C of 1 2, R of 1 2. Likewise, for this complete row we are going to find out the values. Okay, so for these 4 boxes we have to find out the value for weight, cost and root. Okay, again we have to apply the formula by using dynamic programming. Okay, and we have to find out the values. So apply the formulas and find out the values, and mention all that values in a table. So here I am considering that you will solve the example later on. I'm just giving you the overview. Okay, so find out the values and record that in these four boxes. Okay, so after finding out the values are like this. Okay, so in step 2 we have only one value for all the g. Okay, now in next step 3, we'll find w of 02, c of 02, r of 02. Here in this box we'll find w of 13, r of 13, and c of 13 likewise. So we have to find out the value for these three boxes. Okay, so again apply the formula by using dynamic programming and note the values, record the values in these three boxes. Okay, now here you have to remember one thing. In a step 3, while finding out the cost, there will be two values. For each box there will be two values of a, and whichever cost is minimum, that a you have to consider. Okay, for example, see here we have find out the value of cost of 02 by considering a as 1 and again by considering a as 2. Okay, we have to refer the formula for that. Okay, so cost of 02 we have calculated by using two a values. Okay, so final answer is the answer um, minimum of 07 and 08. Which one is minimum? This value is minimum. So if the value of a is 1, then we get the minimum cost. Okay, and that's why the r of 02 is 1. That we have to consider. Similarly, while finding out the c of 1, 3, there are two values of a. A is equal to 2 and a is equal to 3. So, if a is equal to 2, then the cost of 1 3 is minimum. So, a is equal to 2. This 2 will be the value of r of 1 3. Okay, so likewise we have to solve this. Okay, so after solving the complete step 3, this is the output. Okay, in step 4, now there will be three values of a. Okay, so after solving the step 3, this is the output, and finally in last step there will be four values of a's. Okay, and whichever is the minimum, that we have to consider, and that a value we have to record as root. Okay, so after solving the complete example, all the 5 steps, this is the final answer. Okay, so w of 04 is 16. Its meaning is that the OBST, the given OBST has the weight of 16. The cost of OBST is 32 and R of 02 is 2. It means among all these keys, the second key, that is K2, if is root of a OBST. So this is the final answer, and now from this we have to find out the complete tree. We have to build the complete OBST. Okay, but root is this. Fine. So root if second key if is a root of a OBST. Okay, now how to find out the remaining nodes of OBST? Again, for that we have to consider this. How we got the cost of 04 is equal to cost of 04 is 32. So we have to see the solved example, cost of 04. Okay, here the cost of 04 is calculated by using C of 01 and C of 24. Okay, so C of 01 is a left subtree of a node if, and C of 02 is a C of 24 is a right subtree. Okay, so see, this is the root node. C of 01, it means R of 01 is a left subtree. C of 02, it means R of 24 is a right subtree. Okay, so C of R of 01 means 1, R of 02 is, sorry, R of 24 is 3. So again we have to see the solved example. Okay, so C of 01. C of 01, how we got this C of 01? C of 01 is, we have considered C of 00 and C of 11. So C of 00, that is R of 00, is the left subtree of R of 01. See, R of 01 and its left subtree is R of 00. Likewise, R of 11. R of 11 will be the right subtree of R of 01. Likewise, we have to find out the complete OBST. Okay, and the R values are given that we have to consider. R of 01 is 1, R of 24 is 3. So here we have to consider the third key. Here we have to consider the first key, and R of 00 is 0, R of 11 is 0. It means all these are the extended node that are required for unsuccessful search. Okay, so this is the final OBST. Okay, so here I have given just the idea how to solve the OBST by using a dynamic programming approach. Okay, now what is dynamic programming approach? Dynamic programming approach is similar to divide and conquer in breaking down the problem into smaller sub problems. But unlike divide and conquer, these sub problems are not solved independently. Rather, the result of these smaller sub problems are remembered and used for similar or overlapping sub problems. Okay, in this example, we have seen how we got the nodes of a tree from the previous solved cost and root values, right? It means the smaller sub problems, answers of the smaller sub problems are remembered and that are used in dynamic programming approach. So dynamic programming is used where we have problems which can be divided into smaller sub problems, and so that the results can be reused. Mostly, these algorithms are used for optimization. So, whenever the optimum solution is required, dynamic programming approach can be used. The solutions of sub problems can be combined in order to achieve the best solution. Okay, so in short, what we can say about dynamic programming? The dynamic programming should be able to be divided into the problem should be able to be divided into smaller overlapping subproblems. An optimum solution can be achieved by using optimum solution of smaller subproblems, and dynamic programming uses memorization. Okay, so here I have given just an overview of how to solve a OBST by using dynamic programming approach and what is dynamic programming approach. Okay, I hope all of you understood the concept of OBST by using dynamic programming. Thank you.